Hello, my friends. Welcome to this discussion. This is a continuation of our series of partial differential equations. Now, we are going to be talking about the basic applications of Laplace equation. In our earlier discussion, we looked at how we can solve the Laplace equation. In the future, we will be seeing at how we can solve this equation numerically and also application using computer simulations. And another shall come in when we are talking about the derivation of this equation itself. So let's right away look at the applications of Laplace equation in a number of fields of engineering. So one is the electrostatics and magnetostatics, and this equation governs the behavior of electric potential, for example, phi, in charge-free regions. This equation is used in capacitor design and electric field analysis. So in the analysis of these electric fields, you'll find that you'll have vector fields that whose understanding requires the power of Laplace equation. So this equation helps us to solve for magnetic fields in magnetostatics, as we have earlier on said, and this is an application in computing the potential field around conductors. So if we want to compute potential field around conductors, we shall be using the Laplace equation. Another one, field of application in engineering and the computation is fluid dynamics. So we find that in the computation of fluid dynamics, we use the Laplace equation to describe the behavior of incompressible and irrotational fluid flow. So it therefore helps in another way to solve the problems in aerodynamics and hydrodynamics, because incompressible and rotational fluid flow will find these problems in hydrodynamics and aerodynamics. Then an example is when we are predicting an airflow of an aircraft wing. Therefore, you'll find this Laplace equation is very, very paramount. Another area is heat conduction, and the Laplace equation describes the steady-state heat distribution in solids. So for those who are doing the materials engineering, materials analysis, they will find that looking at heat distribution in solids, for example, metals, is very paramount. It is also used in thermal analysis for engineering applications. Okay, so if you're talking about heating, cooling in buildings or in any processes or systems, you need to look at how heat is being conducted, maybe through the materials that have been used to construct that area, and therefore, for you to make a basis of your understanding and doing the thermal analysis, you need a good foundation of the Laplace equation. So we are saying an example is temperature distribution in a metal plate. Yeah, so you apply Laplace equation to look at or to study the temperature distribution in metal plates. So the next is gravitational fields. So in gravitational fields, we are looking at modeling gravitational potential in regions free of mass. The Laplace equation is used in geophysics and planetary sciences. An example that we can look at under gravitational fields is when we are studying the Earth's gravitational field variations. So the Laplace equation will help us to understand that. So another one is image processing and computer vision. So this equation is helping us to understand what edge detection and image smoothing can be, and also helps us to reconstruct blurry or incomplete images. An example is enhancing images in medical imaging, that is MRI and CT scans. So in enhancing images in medical imaging, we find that this equation is very important. Then another area of application is quantum physics in an area of quantum mechanics. And so we find that this Laplace equation appears in Schrodinger's equation in a free particle scenario. And it therefore helps us to describe electronic orbitals in atoms. An example of this application can be wave functions of free electrons in potential free regions. Then in structural engineering, the Laplace equation is used in stress analysis of structures under equilibrium conditions, and in the design of bridges, buildings, and mechanical parts. If we are analyzing vibrations, we want to analyze maybe the earthquake or seismology in areas where we are obviously constructing bridges or these structures. You'll find that we need to understand the basic equations like the wave equation, which later on goes to, when we expand it to the 2 dimensions, then it becomes the Laplace equation. So an example could be analyzing stress in a loaded beam. Therefore, members, thank you for watching, and remember to subscribe, share, and let your bells keep on so that any new updates you may never miss. Thank you.